Okay, so this is part 3 of using the quadratic formula to solve quadratic equations. The solutions in this particular part will contain complex numbers. So remember the square root of a negative 4 would be 2i, so that's an imaginary number. And so if we write it, let's say, write a number as 5 plus 6i, then that's a complex number. So remember 5 plus 6i, 5 minus 2 square root of 3, 5i, 2 square root of 3, 0 plus 6i. Those are all complex numbers. Okay, so that's the kind of solutions that you're going to get in this part. Okay, so let's look at these examples. All right, so we're going to solve by using quadratic formula. So remember, not all quadratic equations can be solved by factoring. On a previous lesson, the ones that we're looking at a while back could be solved by factoring. Now you've noticed in the previous two lessons on using quadratic formula that not all of them can be factorable, so you have to use the quadratic formula. Okay, so let's solve by using quadratic formula. Okay, so remember, quadratic formula. You're talking about a quadratic equation that has this form: ax squared plus bx plus c equals 0. And so to solve this equation, my variable is x, and solve this equation, the quadratic formula will give you the solution. So x equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now remember, b squared minus 4ac is called a discriminant. That was discussed in a previous lesson. So, number 1, suppose we had x squared plus 2x equal negative 5. So x squared plus 2x equal negative 5. Now remember, before you can use quadratic formula, it has to be in standard form. So this right here is standard form. So standard form is where you have all the terms to one side, put in descending order, and you have 0 as your constant on the other side. So in this case, I got to put in standard form, so that's going to be x squared plus 2x plus 5 equal 0. And so in this case, a is coefficient of x squared, so a is 1. B is a coefficient of x, so that's a positive 2. And C is your constant, so that's a positive 5. And then all you do is just plug numbers back into the quadratic formula. So we get x equal the opposite of b. Well, if b is 2, the opposite of 2 is a negative 2. Plus or minus the square root of. And remember, always put, when you replace the variables here with its values, put those in parentheses. So we get b, which is 2, I'm squaring it, b squared, so 2 squared, minus 4 times a is 1, times c, which is 5, all over 2 times a, and a is 1. So simplifying some of these values, we get negative 2 plus or minus the square root of b squared is 4. A negative times a positive is a negative, so 4 minus 4 times 1 times 5 is 20. All over 2 times 1 is 2. Equal negative 2 plus or minus the square root of a negative 16. 4 minus 20 is a negative 16 all over 2. Now let's simplify the square root of a negative 16. Now be careful. That's not the square root of 16, so it's not just 4. So remember, the square root of a negative 16 is the square root of a negative 1 times the square root of 16. And we learned in the previous lesson that the square root of a negative 1 is an imaginary unit, I, and the square root of 16, since 16 is a perfect square, I can write square root of 16 as just 4. So this is 4i. So I get negative 2 plus or minus 4i divided by 2. And we can leave it in compact form, but let's go ahead and kind of simplify this. So you'll notice that all of these numbers here are divisible by 2. So if you want to, you can write, and notice this, you can write this as two fractions. So I get negative 2 over 2 plus or minus 4i over 2, which is negative 2 over 2 is 1, negative 1, plus or minus 4 over 2 is 2, so 2i. And so there's your answer. Now they ask you to write it as two separate, remember that's x. So they ask you to write it as two separate solutions. You're going to say this, x equal -1 plus 2i, comma, and then -1 minus 2i. So those are your two separate, your two distinct solutions, and those are complex numbers. So these are complex numbers. Those are not real numbers, and those are not irrational numbers. Those are complex numbers. Those are not real numbers. Those are complex numbers. Okay, so, all right, so that's number one. Okay, number two, suppose you had x squared plus 25 equals 6x. X squared plus 25 equals 6x. All right, so again, let's put this in standard form, and let's put it in descending order. So I get x squared minus 6x plus 25 equal 0. And now a is the coefficient of x squared, so a is 1. B is the coefficient of x. Now be careful, don't say it's 6, it's a -6. So if any of these are incorrect, then you're not solving this, you're solving a different equation, which is not what you want. And then C is 25, positive 25. C is your constant. Plugging these back into your formula, you get x equal the opposite of b. So remember your quadratic formula, the opposite of b. So if b is a -6, the opposite of a -6 is a +6. Plus or minus the square root of. And again, put all these in parentheses. So b, which is -6, but I'm squaring it, minus 4 times a is 1, times c, which is 25, all over 2 times a, which is 1. Okay, let's simplify this. So I get 6 plus or minus the square root of. -6 times itself is a positive 36. Remember, b squared in the formula, b squared should always be positive unless b is 0. So 0 squared would be 0. But it's never negative. Remember, b squared is never negative. All right, 36. Now a negative times a positive is a negative. 4 times 1 times 25 is 100. All over 2 times 1, which is 2. And so I get 6 plus or minus the square root of -64 all over 2. All right, then simplifying the square root of a -64. Remember, you're taking the square root of a negative number, so that's the same thing as saying square root of -1 times square root of 64. Square root of -1 is I. Square root of 64 is 8, so you get 8 times I. So you get 6 plus or minus 8i divided by 2. Now again, just like in the previous problem, I can reduce this, so go ahead and simplify it further. So I'm going to get 6 over 2 plus or minus 8i divided by 2, which reduced is 3 plus or minus 4i. So that's what x equals. So x equals sit with two solutions. This is really two solutions. You just write it in a compact form. Now if they ask you to write this as two separate solutions, your solutions would be written as 3 plus 4i, comma, 3 minus 4i. So again, those are your complex solutions. All right, number 3, you have, let's say you had 4x squared minus 4x plus 19 equals 0. So 4x squared minus 4x plus 19 equals 0. Okay, so it's already in standard form, so let's determine what a, b, and c are. So a is the coefficient of x squared, so a is 4. B is the coefficient of x, so that's -4. And c is your constant, so that's 19. And then plug in back into your formula, you get x equal. All right, so the opposite of a -4 is a +4, plus or minus the square root of b squared, so that's -4 raised to the second power, minus 4 times a times c, all over 2 times a, and a is 4. So all I do is just plug these values back into the formula. So I get x equal 4 plus or minus the square root of, okay, negative 4 squared is 16. A negative times a positive is a negative, and then 4 times 4, that's a 4, is 16, and then 16 times 19, use your calculator, 16 times 19 turns out to be 304, all over 2 times 4, which is 8. So I get 4 plus or minus the square root of, alright, 16 minus 304 will give you a negative 288 divided by 8. So that's where we're at. Okay, now 288 is not a perfect square. But let's determine, besides 1, if there's a perfect square that goes into 288. Now remember, that's negative. So I really get a negative 1 times the square root of 2, the square root of negative 1 times the square root of 288. The square root of negative 1 is I. Now let's simplify 288. So I'm going to go right here and do that. So the square root of 288. Alright, so let's see if 4 will go to 288. So 288 divided by 4 equals 72. So I get 4 times 72. Now what I want you to notice though is this. 4 is not the largest, because if you look at 72 right here, I can write this as 36. So 36 times 2. And so the largest will be 4 times 36. That would be the largest. So 4 times 36 will give me 144. So this right here is really the square root of 144 times 2. Now again, if you couldn't figure out what I just did, hopefully you can, but if you couldn't, you could have still, I'm going to show you, you could have still have just used 4, but you would have had to do a bunch of steps. So for example, let's go back to square root of 288. So let's suppose you could only see that 4, the perfect square of 4, goes in 288. So you'd say 4 times 72, and then you'd say the square root of 4 is 2, so I get 2 squared is 72. But then you have to look at 72. So you got to ask yourself, can I simplify the square root of 72? So you look at all these perfect squares that may go into 72. And the idea, though, is to always use the largest perfect square because it saves you some steps. So you would say 2 times the square root of. Now, hopefully, you could have noticed that 36 times 2 is 72. But if you couldn't, then try 4 again. Try the next perfect square beyond 1. So 4. So 72 divided by 4. I keep messing this up. 72 divided by 4 is 18. So I can write this as 4 times 18. And then you have the square root of 4, which is 2. So you have this 2 times this 2 times the square root of 18. So I get 4 square root of 18. But then you notice, hey, that's not simplified. I can go further with this because 9 goes in 18. So then I get 4 times the square root of 9 times 2. The square root of 9 is 3. So I get 4 times 3 square root of 2. So that's 12 square root of 2, which is what, remember, notice the steps. So the square root of 288 would be 12 square root of 2, which I would have gotten just by thinking about it this way, because the square root of 144 is 12, so I get 12 square root of 2. Okay? So over here, then, what that's going to become is this. I'm going to get equal 4 plus or minus I. Remember the I here. Square root of negative 1 is I. Well, 12i. Let's write this as 12i square root of 2. That's a square root of 2. 12i square root of 2. All over 8. Okay, now I want you to notice this. 4, 12, and 8. There are several ways to write this. If the direction says to simplify, they're talking about simplifying the radicals, and they're talking about reducing as part of the simplification. So reducing as much of this as possible. So there are several ways to do this. You could look at these three numbers right here, 4, 12, and 8. So those are all factors. 4 is a factor, 12s of, well, let me rephrase that. Look at all these terms, I should say. So 4, and then this term has 12 as a factor in it. This term has 4 as a factor in it. And this term right here, the denominator, has 8 as a factor in it. And all of these terms here are divisible by 4. So basically you're saying 4 into 4 is 1, plus or minus 12 and 4 into 12 is 3, and then 4 into 8 is 2. So that would be an answer you would write. Now if you wanted to, you could have done this. You could have said, all right, well, I can write this as 4 divided by 8 plus or minus 12i squared root of 2 divided by 8, and then reduce that. So reduce this part. So I get 4 divided by 8 is 1/2, plus or minus, and then 12 divided by 8, 4 goes into both of those, so that's a 3, that's a 2, so here's that 3 and the 2 that you just saw. So that's 3/2 I squared root of 2. Alright, so that's another way of writing it. Now, since the denominators are the same, you can just write this as 1 plus or minus 3i squared root of 2 all over 2, which is what this is. Alright, so there are multiple ways of writing the answer. Now, if you're told to write this as 2 separate solutions, then again, multiple ways of writing that. So you'd say, going back over here, you'd say 1 plus 3i squared root of 2 over 2, comma, 1 minus 3i squared root of 2 over 2. Or you could have written it as 2 fractions. So you could have said 1 over 2 plus or minus 3/2 I squared root of 2. I'm sorry, plus. Okay, there's the plus. So 1 over 2 plus 3i squared root of 2, comma, 1 over 2 minus 3i squared root of 2 over 2. So all of those are correct ways of writing the solutions. All right, so that was number 3. All right, let's look at number 4. All right, number 4. All right, suppose we had, let's see. All right, suppose we had this. 9x squared plus 6x plus 37 equal 0. 9x squared plus 6x plus 37 equal 0. Okay, so A is 9. B is the coefficient of x, so that's C, and C is your constant, which is 37. Okay, so let's plug that back into the formula. So I get this x is the opposite of b, so b is 6. The opposite of b is negative 6, plus or minus the square root of. All right, so I square b. So see, I put 6 in parentheses. I'm going to square it. Minus 4 times a is 9, times c, which is 37, all over 2 times 9, 2 times a, so that's 2 times 9. So I get negative 6 plus or minus the square root of 36. 6 squared is 36, minus a negative times a positive is a negative. All right, so we got to figure out what that is. So 4 times 9 is 36, and then 36 times 37 on your calculator gives you 1,332 all over 18. So I get negative 6 plus or minus the square root of, all right, 36 minus this, so 36 minus 1,332 equal 1,296, negative 1,296. Okay, so all over 18. Now, first of all, let's see if 1,296 is a perfect square. So just on your calculator, so 1,296, if I take the square root of that, I get 36. So this is a perfect square. So always look at that first. Is it a perfect square? If you get a decimal, then see if there's a perfect square that goes into it. Now, before we go on, I want you to remember something. This is kind of review from previous lessons. You see, this is your discriminant. So this whole part right here is a discriminant. Well, it turns out the discriminant is negative. So if the discriminant is negative, you're going to get complex solutions. All right, you're going to get two complex solutions if the discriminant is negative. So since the discriminant is negative, and negative I'm right as less than 0. So less than 0 means negative. So since the discriminant is negative, we get two complex solutions. All right, so two complex solutions. So in this handout that you received, so characteristics of solutions of a quadratic equation, so the discriminant is positive, you had two unequal real solutions. I remember we went a little bit further with that. We saw that if it's positive, it was either going to be a perfect square or not. If it's a perfect square, they were rational. If it was not a perfect square, they were irrational. If it's 0, if the discriminant is 0, we haven't done one like that yet, but we will. I think we did. Let's see. If the discriminant is 0, you're going to get one solution, but it's a repeated. It's called a double root, so it's a repeated solution. I'm trying to see if yeah, we did. So it was this one here in a previous lesson. So you see right here, discriminant is 0. Discriminant is 0. So you had, and when you did the 2 plus and the 2 minus, you had the two solutions being the same, so the repeated solution, but you only listed once. So you just said x equal 1. So that will be called a double root or a repeated solution. So we prefer to use the word double root. So right here, double root. Okay, so that was in part B. No, part A it looked like. So that was in part A. All right. And then if the discriminant is negative, we're going to get two complex solutions. Okay. All right. Now, so this right here is going to be a negative 36. So I get equal negative 6 plus or minus. Oops. Let me write it. So negative 6 plus or minus 36i. Okay, because the square root of negative 1 is I. All over 18. And then again, always make sure, remember simplifying means in this case also to reduce. So 6, negative 6, 36, and 18, 6, 36, and 18, they're all divisible by 6. So I can rewrite this as 6 into negative 6 to negative 1, plus or minus 6 into 36 is 6, I, and 6 and 18 is 3. So I can write the answer like that. If I want to, I can take this part here and write as two fractions and then reduce. So get x equal negative 6 over 18 plus or minus 36i over 18. And then reduce. So that's going to be negative 1/3 plus or minus, and then 36 over 18 is 2. So that's another way of writing the answer. So multiple ways of writing the answer. If you want to write it as two separate solutions, there are multiple ways of writing that as well. So look at the different ways. Let's use this one here. So I can write this as negative 1 plus 6i over 3, comma, negative 1 minus 6i over 3. If I use this one, I can write it as negative 1/3, x equal, negative 1/3 plus 2i, comma, negative 1/3 minus 2i. So those are all multiple ways of writing solutions. Okay, so that was number 4. And then let's do one more. Let's look at this one. So this will be number 5. So number 5, you have, let's see, let's say you had x squared plus 2x plus 6 equal 0. So x squared plus 2x plus 6 equals 0. So A, it's already in standard form, so A is 1, B is 2, C is 6. And then it's just a matter of you plugging these values back into the formula. So I get x equal the opposite of b, so b is 2. The opposite of 2 is negative 2, plus or minus the square root of b, which is 2, in parentheses I square it, minus 4 times a, which is 1, times c, which is 6, all over 2 times a, and a is 1, equal negative 2, plus or minus the square root of, okay, 2 squared is 4, minus, that's going to be 24, all over 2. So negative 2 plus or minus the square root of 4 minus 24 is a negative 20 all over 2. Now let's go ahead and, now square root of 20 is not a perfect square. So, but I do know that the square root of negative 20, I can write as negative 1, square root of negative 1 to the square root of 20. Square root of negative 1 is I. And I do also know that 4 will go into 20, so that's times the square root of 4 times 5. And the square root of 4 is 2. I get I times 2 square root of 5. And so when I rewrite it, though, we always put the I between the whole number part and the radical and the square root part. So I get 2I square root of 5. So that goes here. So I get negative 2 plus or minus 2I square root of 5 all over 2. And then again, notice that all of these numbers here are divisible by 2. So you really should have negative 1 plus or minus I square root of 5 as your solution. Now, you could have seen that if you didn't see what I just did, you could have seen that by just rewriting it like this: negative 2 over 2 plus or minus, that's x equal, plus or minus 2I squared root of 5 over 2. Negative 2 over 2 is 1, negative 1, plus or minus 2 over 2 is 1, I squared 5, square root of 5, and that's what you got here. Now again, if they ask you to write this as two separate solutions, you would say x equal negative 1 plus I squared root of 5, comma, negative 1 minus I squared root of 5. So all of those are correct ways of writing the solution. And so that's the end of part 3. So part 3 just dealt with complex solutions. And remember, we got complex solutions because the discriminant, this is your discriminant is negative, and when the discriminant is negative, when the discriminant is less than 0, that means negative, you get two complex solutions. Okay.